Welcome to this explainer. Okay, today we are exploring something pretty mind-blowing, the invisible intelligence that is literally processing millions of data points every single second just to protect our money and curate our digital lives. We're drawing directly from Dr. Ritesh Ratti's book, Ultimate Machine Learning Algorithms with Python, and we're going to skip all the dense manual programming stuff. Instead, we're diving straight into how machines learn patterns all on their own. Specifically, we'll look at two massive real-world applications, fraud detection and customer segmentation. Let's get right into it.
Picture this for a second. You're sitting on your couch at home, and suddenly your bank texts you, "Hey, did you just try to buy a $3,000 TV across the country?" And you're thinking, "No way, but how did they know?" Well, losing billions of dollars to fraud is a massive headache for businesses, and the old-school traditional rule-based systems just can't keep up anymore. But machine learning algorithms, they process these transactions in real time, instantly spotting those fraudulent patterns before the purchase even goes through.
And that brings us to the very first side of the machine learning coin, supervised learning. The best way to think about this is like a student studying for a huge test, but they already have the answer key sitting right in front of them. The algorithm is fed labeled data, so basically a ton of historical examples of exactly what normal looks like and exactly what fraud looks like. From there, it learns the mapping function from the inputs to the outputs, allowing it to predict future anomalies with just crazy accuracy.
When you take this supervised student and actually deploy it in the financial sector, the results are staggering. I mean, it is catching credit card fraud in actual milliseconds. It's flagging complex money laundering across massive global networks. It's even preventing identity theft by using behavioral biometrics, which is literally analyzing things like how fast you typically type on your phone. Because it knows exactly what specific target it's looking for, this tech is saving industries billions of dollars every single year.
But here's where we hit a big pivot in the machine learning world. See, supervised learning requires a ton of human effort up front. Somebody actually has to sit down and label all those features and target outcomes. But what happens when you don't have that answer key? What if you're just staring at massive mountains of raw data without any clear target? Well, you're essentially flying blind. And to handle that, you need a completely different approach. Enter unsupervised learning. Since it doesn't have an answer key to study from, this algorithm acts much more like an explorer. It dives headfirst into all that unlabeled data to discover patterns, groups, or inherent structures that we honestly didn't even know existed. It's not trying to predict fraud or not fraud. It's just analyzing the entire landscape and naturally grouping together things that are similar.
So, how does this explorer actually tackle real business problems? A perfect example is customer segmentation. An unsupervised clustering algorithm can analyze literally millions of e-commerce users all at once. It's looking at your purchasing behavior, your demographics, how you engage with a site, and then it automatically groups everyone into meaningful segments without any manual tagging whatsoever. This is exactly how businesses are able to launch those highly personalized marketing campaigns that seriously boost their conversion rates.
So just to quickly summarize Dr. Ratti's core distinction between the two. Supervised learning is all about predicting specific outcomes, but it demands high human effort because of all that labeling. It is absolutely built for prediction and classification. Unsupervised learning, on the other hand, requires very low human effort since it relies purely on unlabeled data, making it your absolute go-to tool for exploration and clustering. Basically, these are two very distinct tools designed to solve two totally different enterprise problems. Which really leaves us with this one final, kind of wild thought. As you go about your day today, swiping your credit card, streaming a movie, scrolling online, how are these algorithms categorizing you right now? Are you just a behavioral biometric data point in a supervised fraud model, or are you a brand new variable in an unsupervised cluster that's actively shaping tomorrow's marketing campaigns? This invisible intelligence is always learning from us. Thanks so much for joining me for this explainer, and definitely keep your eyes open to the data all around you.